That's the thing I always forget.
Got it.
Okay, thank you very much, John. Please proceed.
Yep. All right, let's get back to it. So Bob asked me to talk a little bit about the incubation work and some of the liming research. I was involved with Iowa State. Most of that was part of my master's work with Antonio in Ames. And so what I'm quick gonna, it's not a lime presentation unless you show someone from the 1940s applying lime with a horse-drawn buggy. So what I just want to touch on quickly today are some key trends that kind of set up this research. I think it's always good to kind of put things into context of why the work was needed within the state of Iowa. And I'll talk about an incubation study, a paired field study that was really derived from the results of the incubation. Some of the applications of the findings and how those were used in updating the state recommendations. And I'll put an asterisk by that saying still trying to update the state recommendations, because with a lot of Lyme laws, there's some legal kind of codification that has to happen with those. Implications for other incubation studies related to kind of this specific aim, and then some ongoing work and future work that I do with liming soil pH here in Wisconsin now. So kind of a tale of two trends. I wanted to start off with just a little bit of background. In the last 30 years in Iowa, we've seen changes in precipitation patterns, mostly in terms of intensity, not necessarily in overall annual precipitation. Our tile drainage discharge has increased about 16%. That was done by a study of a USGS and University of Iowa scientists. And then the state's average nitrogen application rate has increased quite a bit over the last 30 years and going back. There's also been an increase in no-till acres, but then also manure applications are something that are really important to consider as well. And the figure on the right is from some work I did with some nutrient GIS work looking at different nitrogen balance components. But when we look at nitrogen fertilizer and manure N, those are both nitrogen fertilizer N and manure N applied to cropland acres within the state of Iowa, certainly we see a trend that would lead us to think about the acidifying effects of nitrogen fertilizers. And some of the work out of Iowa State estimated that up to 70% of that would be ammoniacal fertilizers as well as the N fertilizer source. As well, the bottom bar chart is from the 2020 soil test summary that Tom and I did. And then the chart on the top right is just some Sergo data applied to 15 centimeter soil pH. But we can see that we also have kind of this interesting dynamic of inherent soil properties and then management effects. The map you'll see is definitely related to inherent soil properties, our texture, parent material, annual precipitation. But as we see the change from 2001 to 2020 in the bar graph, we can see that we're seeing a higher frequency of pHs below 6.5 within the state over that 20-year time span, and reductions, which we would expect in pHs above 6.6. And again, those are kind of inherent versus management, which our Lyme studies really try to address. Some observations that we saw in on-farm water quality studies, we saw interesting relationships between crop grain yield and soil pH. This wasn't necessarily a liming or a pH study. This was actually a phosphorus runoff study, but these are from production fields that had no other treatments besides phosphorus applied. And so we saw some interesting trends that really needed to be addressed as well. And so then the questions from the Farmgate started to arise. This is just another example of in Southwest Iowa, comparison of very different management histories between these two sides of a range here in plots. But you can tell that obviously we have a liming history on the left and not on the right, and that really affected what was going on in this cropping system because nothing else was different. And so really concerns led from the Farmgate were what is kind of some efficiency of all these liming materials that are popping up. What is the crop response to ag lime that we should expect? And that's kind of a big, I think, talking point when talking to farmers is, are we really seeing a crop response to liming, or is there some other interaction going on? And then we looked at some site-specific identification and treatment of acidic soils, but I won't get into that, that precision ag piece today. So really what it came down to was needing kind of a multi-scale investigation. You can see where the different sites were across the state in Iowa and some physiographic soil regions. But there was a lab incubation, multi-site plot scale work, and then there was, again, some site-specific precision ag work. I'll focus on the incubation and some of the material efficiency and see how that kind of informed some of the other work as well. So the incubation study that we did, really, we kind of based it off two manure incubation studies that Dorvar Ruiz-Diaz did with John Sawyer at Iowa State, and then Antonio had done with a beef cattle manure incubation as well. So in terms of the design of the study, we really used that mostly because it was done in the same space. And so it really made sense to look at what was being done in terms of the work there. We collected bulk soil from the top 6 inches from 3 different sites across the state with pretty contrasting properties, mostly looking at texture and some differences in parent material. Those soils were kind of processed typical to a controlled incubation. These are not intact, soil cores put in the cups. So they were dried, crushed. We mixed them in a cement mixer and air dry sieved them. And then they were brought up to field moisture capacity, and we determined that so that we could tell how we can manage the soil moisture throughout the duration of the incubation. And I'll talk a little bit about that later, but that really soil moisture and gas exchange were something that we were really concerned about and wanted to make sure that we got right. Not saying we definitely did everything perfect, but I think when you're trying to manage thousands and thousands of incubation cups within a chamber, you have to get a little bit specific. The mixtures were kept at about 70 to 80% field capacity, and then the collection times, if you will, were a certain amount of weeks throughout that incubation period. And so I'm just going to jump into some of the results, and then if there's anything with the methods that anyone has questions about, please feel free to stop and yell something out. So when, part of this research was really wanting to look at different fineness factor efficiencies, right? We talked about the material efficiency question that people had, because liming material fineness is so different when you go to different quarries, the amount of ground and stuff like that. And so what we also did was look at different sources of lime as well, because on the west versus eastern side of the state of Iowa, you could have very predominantly calcitic lime quarries versus dolomitic lime quarries. And so what we really found was that, in terms of the fineness effect, that wasn't a surprise. The finer material and these are US Tyler sieves for reference here in the numbers. So 4 to 8, 8 to 10, 20 to 60, 60 to 100. And I'll say the Iowa lime analysis sieves that they use are 4, 8, and 60, passing those specific sieves. And so we really didn't, this wasn't a surprise to see the fineness effect on increasing soil pH. But really, we did see some interesting trend differences between the two sources, calcitic versus dolomitic ag lime. And of course, those are treated the exact same within the liming recommendations for the state of Iowa. I don't know if David Hardy's on here, but I think North Carolina treats them differently as a state that might have a modifier. But that was something that was interesting as well. So again, these trends necessarily aren't groundbreaking, obviously, but they inform some later work as well. And within that same incubation study, we had kind of as is lime products. So we had reagent grade calcium carbonate as our reference. We used a pelleted lime product that was from Calcium Products, who are based in Ames. We used, I think that was their 98G is the brand name. And then just kind of a calcitic and dolomitic lime. If you want the specifics on the ECC, I can pull those up a little bit later too. And then we can see the control there. And so these necessarily weren't unexpected either. We saw a quicker reaction from the calcitic lime compared to dolomitic lime. The pelleted lime, from the information we got from the provider of the product, it was essentially ground to 100 mesh and then agglomerated. So that's really, really fine lime within that pellet. And I think that's why we saw probably kind of a little bit quicker and sustained reaction. But as we talked in the meeting last month, an incubation condition is very different than field conditions, and whether that pellet does get dissolved and broken up is another question in the field. And so really what we wanted to do then was kind of map the, based on the particle size, the efficiency of the two sources. And so certainly we see different trends that probably need to, it probably points to needing to treat calcitic and dolomitic lime a little bit different in terms of how we evaluate them on their ECCE. Dolomitic lime, naturally with magnesium carbonate, is going to, when you do a hot digestion, the ECCE is probably going to come up a lot higher than calcitic, or it's going to be higher, whether that's before applying a fineness factor. However, the reaction time is just so much slower that in terms of the efficiency of the product, it was essentially lower when we did a kind of on a time-by-time basis and assessed calcitic versus dolomitic. But we see the same trend for both sources. Some other options within incubation, something that we looked at, which is kind of just a side study, or a side treatment, I would actually call it within the study, is we wanted to simulate what would happen. Everything else that I've shown up till now was kept at a constant moisture and temperature. What would happen if we re-wet up to field capacity and then had a simulated tillage effect? Does that affect anything or not? If it doesn't, that's fine. If it does, maybe it's something to take a look at, and we should be considering those tillage events a little more seriously in the field research as well, or sampling before and after them. And so we saw slight increases in pH after that re-wetting and mixing effect. Essentially, you can kind of see it was done at about 140 days up to the extent of the incubation. No real difference between the sources in terms of how much the pH increased. Again, that's a really, really small increase in fluctuation. There might be some insights into some moisture and soil disturbance, essentially kind of speeding up some of those essentially reaching some surface reactions that weren't available previously. But we're also working in a confined incubation cup. So when you reach a certain level of saturation, within the condition around that lime particle, you might be kind of limiting those reactions and gradients as well. So that's something to consider. And so really what we wanted to do with this, because there really wasn't any documentation of the fineness factor efficiencies of lime particle sizes, we had these numbers on the far right here, the Iowa Department of Ag and Land Stewardship fineness factors applied to each mesh size. So we had 0.1, 0.3, and 0.6. Those were used within the fineness factor calculation to eventually calculate effective calcium carbonate equivalents. And so our experimental efficiencies here, how we gauged efficiency was in relation to reagent grade calcium carbonate. So that particle size was essentially just divided by the amount of pH change by the calcium carbonate. We just use a proportionality within kind of the given sample or the given range of particle sizes, and to essentially fit those efficiencies down to 100%. When we did that, well, lo and behold, we actually got pretty similar numbers to what the fineness factors were in Iowa. And so in terms of, and again, this is for all the liming sources, calcitic and dolomitic combined. So, maybe pulling that apart is what we thought would probably be a better idea, in having a calcitic and dolomitic fineness fraction, or just take some kind of modifier. I will say, when we presented this to the Department of Land Stewardship and some of the Iowa Ag Lime Association, having an idea that maybe we could add another sieve to kind of tighten up this efficiency and actually assessing lime acid neutralization potential. They weren't too happy with adding another sieve to the assessment size, and the kind of bureaucracy with changing lime laws is something that it was interesting to witness firsthand. But regardless, we got a lot of the findings out to growers and agronomists, and so that was really where the rewarding part of that was. So another question that was interesting is, can you really reach a maximum pH, or is there going to be some type of spatial or honestly chemical constraints? Like I talked about the gradients within that cup that you're using for an incubation. And we really had a wide range. This table, don't get bogged down within the models that were fit to the pH change over time, but the max plat is just the maximum or plateau that was reached at a certain number of days within the incubation. And we saw a really wide range obviously across not only the particle sizes, but also between sources. If you look at the calcitic egg lime, it was about 46 days we kind of peaked. Dolomitic lime was 137. So we kind of saw that reaction, but the calcitic egg lime peak or max was a higher pH. And so what we then wanted to, we talked about the max pH and do those days really reflect something that's going off in the field, or are we just controlling things almost too much within the incubation? Well, this is some older work that Antonio had done with one of his PhD students a few, maybe like a grad student generation before I was there. But looking at just 3 different sources of liming materials, and the maximum or plateau fit to these points essentially was around 150 days they reported, sometimes a little bit earlier. When you really look at those plateaus, they're probably honestly under 100 days. So that made me think, maybe this incubation results aren't that out of the park in terms of saying this could actually happen in the field. I don't want to get bogged down too much, but this is, kind of that variation that I talked about earlier. This was the multi-site study. And again, this will be recorded, so it's available for people to look at later as well. The green letters and numbers essentially are the surface texture, the CEC, and then the percent soil organic matter. This is for control treatments and looking at pH over time over a 2-year study. And you can see that these fluctuations, they start to occur, sometimes a little bit differently in terms of their magnitude at the sites. The red arrows are actually when nitrogen was applied in the spring in the first study. It was corn and then soybeans. But kind of interesting to look at these trends over time and see this variation. And again, that's just something that isn't necessarily always easy to represent within an incubation study.
Hey, John, is that
Yep.
Is that 0 month? Is that January?
No, that's just the beginning of the study.
Do you know what the date was?
So that's going to be.
Where I'm coming from is we do see natural
Yep.
fluctuations that happen in pH, in the summer or on
That
dry
might
months.
be.
Could it be like March?
I was going to say, I think it's a few months after the start of the year based on those precipitation numbers, because it would, you would certainly see you'd see that spike. So yeah, I think we're looking at February or March. So pretty close. April.
Okay, thanks.
Amber, sorry. And so that variation is something that was kind of hard to address in the field studies. And, are we really matching that and making that representative in the incubations as well? I think it's something worth considering. And those same field studies then looking at the crop response to liming. And again, I kind of use that term with a little bit of hesitation because I think it's more of creating that pH that other yield limiting factors maybe aren't playing as big of a role. But we start to see on the y-axis here is the relative crop yield increase, and naturally as we move to a pH where we would expect optimum productivity, we see less yield increases essentially within those liming experiments. On the left is soil pH, and on the right is Socotra buffer values as well. And so you can see some separation between higher and lower buffered soils as well. And interestingly enough, on the right, we kind of look at, Luke talked last week really about kind of the basics of, essentially our base ratio and base saturation versus soil pH, and how we have these different components of a trend when we move through those relationships. But when we're looking at some of our water quality studies as well, we start looking at the soil pH of these on-farm experiments, and they have an interesting relationship between what we would expect between extractable aluminum and iron. But then when we're measuring essentially phosphorus saturation, just using a Mehlich-3 extracted P, aluminum and iron, we certainly see that relationship, which is something that I think consider when we start talking about water quality experiments and metrics that we use to predict runoff loss in this case. So now kind of it comes to updating the state recommendations and the story of, we did all this work, we presented it to the Department of Ag, and what did we get out of it? We did get some great interaction between growers, crop consultants, and getting the information out there and published. But essentially what we came out with a recommendation is that calcitic and dolomitic ag lime probably need to be separate in terms of their ECC recommendations, just because of the rate of reaction. Adding a 20 mesh sieve size to the a lime assessment or lime analysis would be ideal in terms of what we saw in identifying the differences, because there's such a large difference between the 8 mesh and the 60 mesh lime size. Wasn't necessarily met with the most positive response in terms of sieving to another size, but it was something to consider. And I think some of the smaller ag lime companies or even pelleted lime companies started thinking about maybe we need to look at how we analyze lime in terms of its efficiency in the field as well. And so kind of both lab and field studies, what did they really suggest? Nothing really, again, groundbreaking on that finer material leading to greater or more neutralization of acid, the chemical composition and the calcitic with dolomitic ag lime. On the crop response side, and these are only the responsive sites, I'll say responsive sites for about 2/3 of the time within 6 sites and multi-years across the state. And the liming sources really didn't differ that much in terms of our crop response to liming. And again, we looked at our effective CCE. So this is taking into consideration fineness on the x-axis here, corn and soybeans on the left and right. And so the rate really determined the responsiveness. And optimum yield and positive ROI for soils under pH 5.5 usually was with about 2 to 4 ton of lime application. And I will say those kind of idealized pHs of 6 to 6.5, they really didn't show up as well as we would have thought within our cropping systems within the state of Iowa. We saw that threshold more down around 5.5 for most corn and soybean systems. I would be remiss not to talk about economics of all this. My wife and I have a small farm here in Wisconsin, so I'm a farmer who will attend things for free lunches as well. But when we look at the kind of the return on an ag lime investment, if you look at these, the colored dots are years within a rotation. The dashed line is essentially the difference between a positive ROI and a negative ROI on a lime application. And then we have for 3 different price ratio scenarios for corn and soybeans. And you can see that, when we get to $5 corn, $10 soybeans, which, is about where we're at for corn now, a little bit lower on soybeans, it really takes until that 3rd or 4th year, maybe in the 2nd year, to break past that dashed line in terms of getting a profitability on that ag lime application. Now, if you have prices pretty darn close to what we have right now in terms of contracted crop, you can get that line is paying for itself a little bit faster. Again, dynamics of what's going on in the field and then also what's going on in the market. When you look at pelleted lime, and these prices are, I had this on the slide, I don't know why it's not showing up. These prices for ag lime and applications are about 5 or 6 years old now. But the pelleted lime really only paid for itself at the higher grain price, and really only in the 3rd, maybe in the 4th year. So that's something that really needs to be communicated as well. Some final considerations for incubation studies. They're useful, I think, in terms of studying a single component of soil pH and liming reactions. I would say to let them guide your field research. Use them as a step in the multi-scale approach. Monitoring moisture content, having one thing, I wish I would have taken more pictures of our setup, but we had our scale on a cart essentially that we could drive around throughout the incubation chamber, and make sure that we were measuring cups all over to hold consistent moisture. That was really important. Making sure that there is some gas flux between those cups and in the atmosphere was something that we wanted to make sure that was done. And you can even see in the red circles here, on those more coarse particles, those were the particles of limestone that didn't react throughout the incubation. And a direct reflection of field conditions is kind of impossible sometimes, but we keep that in mind when planning the studies and eventually publishing them or getting them to stakeholders who use them. And again, on the bottom right is just fluctuation in pH throughout a 2-year study, and how that trying to represent that within an incubation study is also really difficult. Some ongoing future work in pH and acidity that I'm doing now in Wisconsin. We have some long-term pH plots up in northern and central Wisconsin. this figure, you can kind of see the more yellow polygon map units are soils that would be below 5.3 pH, essentially some more naturally occurring acidity that would be occurring up there. We also have some liming rate and frequency studies on the right side of the state, or the east side of the state. We have some more calcareous soils that we're looking at, some maybe inefficient phosphorus tests that right now in terms of referencing the Bray 1 test, and I'm working to calibrate other phosphorus tests for the state. And in the central part of the state, we've got quite a bit of, I would say, aggressive tillage that goes on. And so we have a lot of nice eroded knolls that are exposing some carbonates and till under those lust caps that we're addressing as well, in terms of the variability and site-specific nature of lime applications and where they would work. Hopefully I kept that pretty quick. Thanks. I appreciate the opportunity to come and share some of this work. And I know, Bob, you've got a few other things to catch in the meeting agenda. So I can take some questions, or hopefully this guides some discussion.
No, I think this is excellent. I mean, this wasn't quite, you always come to a presentation, I think you've got some expectations, and I think you really added some dimensions to that expectation. Quick question. What's the definition between calcitic and dolomitic lime? I mean, what's the magnesium, what's the swap over there?
I think the Soil Science, and anyone correct me if I'm wrong, but I think the Soil Science Society uses 12 or 14% magnesium carbonate.
To me, okay, if that's the swap point, boy, you get to some markets and I think you probably reach 50% magnesium carbonates, right? And so to me, it really depends on where that mine is and how far that difference is between. What do you know what the magnesium content of your dolomitic lime was for your study?
Yep. I'll pull it up really quick.
It's one of those things, we all live in our little worlds, and I wasn't quite aware that I knew dolomitic had less effectiveness, but boy, what you kind of showed there, it was pretty significant.
I wasn't aware that there's actually a agreed upon definition of what dolomitic lime is. I've looked for that before, and I have not been able to find it. So correct me if I'm wrong, but I didn't know that AAA had adopted a definition. Yeah.
Well, I'll find it. I referenced it in my master's thesis, but I'll find it and send it out. I mean, it took some searching to find it, but so this limestone, only the dolomitic lime had 13 to 14% magnesium.
Yeah, and so that's a pretty pronounced effect for 13%. And again, we don't know what your magnesium content of your calcitic was, but
it was 0.13 to 0.15.
Wow. So, but my point is if you go up to 30-40% dolomitic type or magnesium content of your dolomitic lime, that has a very much more pronounced effect.
Yeah, and I don't have experience with that high of manganese content, so I'd have to kind of refer to some. I know in parts of maybe I think Indiana has quite a bit of dolomitic lime that gets applied there, but I'd have to refer to someone who's working in those areas. But yeah, Luke's not on and David's not on. I think North Carolina treats dolomitic and calcitic ag lime different in terms of the recommendation.
Yeah, but what I'm saying is you don't have two classifications, you have a gradient, right?
Yeah. Yeah.
Yeah, no, we hit some 20-30% here. And so that's really got me rethinking. I would never have thought that degree, especially if you're at 13%. And I want to jump in, John, I forgot. I might have missed, I had students running in. What was the price points that you used on the economic analysis for the ag lime and the Pell lime?
Yep. And I can.
Because actually our Pell lime is a lot more expensive, and I think it'd have to take a lot higher corn value to get there.
So for the limestone, I used 125. Okay. Got these stacked on each other here. I used $12 per acre for tillage and incorporation. I think I used $125 per ton for Pell lime, and I think $60 per ton for ag lime.
Oh crap. We're at 15 and 2 something.
Excuse me.
Yeah. We're usually anywhere between 15 to 25 applied per ECCE, and our pill lime is 10, at least 10 times greater per ton.
Yeah, I've heard of pill lime being around the 200s around here too. I haven't heard in a while, but that's the last I heard. While our ag lime is 70 to 80, but we're a little bit different in Oregon. We're really far away from lime mines, so they just always run high.
And those are, you know, like I said, those are probably data from, or price points from 2016, I would say.
So
So that could change. Definitely application costs have changed.
The varying cost of lime by environment, because even parts of our state, I mean, we'll get up to 80 or 90 if we're with, especially a $6 diesel, if we're away from the quarries. But our range in Oklahoma is anywhere between 15 to 65 applied, depending on where you're at.
Yeah.
So that
I think
itself, as an analysis, is interesting.
Yeah, and I think it's the ground, you know, it's the grinding process that's really expensive, because I've got limestone in my barnyard that costs $12 a ton that you know it's coarse. We just wanted it for our shed in our barnyard, but so it, you know, I would be interested, and I've searched for this data and I cannot find it, even with the folks at TFI and DC wanting to know the spatial distribution of lime sold. It's really difficult to get that data.
Well, oil and gas exploration and wind energy increases the cost, because they'll take half-inch chunk at the same price as ag lime. So that's an interesting. I had, what was it? There was one more. How many of you guys, I'm interested because we brought into this, when we're starting to do this, you're talking about lime, how many of you are incorporating the aspects of herbicide breakdown when you're starting to talk about soil acidity? I mean, atrazine, sulfonylureas, many of these basically lose majority of their effectiveness when you sub 5.5. So there's a huge economic value if you start talking about the residual effect of atrazine being gone in like 5 days.
I hadn't realized it was the breakdown was that quick.
Atrazine and sulfonylureas are really, really quick. Their half-life basically goes to a week or two at a 5, something like that. I've got an older paper we've done here, but I've stopped talking about impact on nutrients and just straight up talking about herbicide.
Well, between that subject and what John showed, what happens to corn and soybean yields, again, 5.5. You know, I mean, 5.8 didn't seem to have any differences, but once he hit 5.5, it fell apart. So.
Yeah, and I would, you know, maybe this also supports Brian's point on framing the discussion around response to liming. I don't know if we're necessarily seeing a great response in terms of the liming application. I think it's multiple interactions between nutrients and other components of the system. And so, you know, looking at nitrogen use efficiency and things like that is probably maybe a little more accurate assessment. But.
Okay, any more questions? We got time.
I had a question, John. On your mesh sizes and the effectiveness or efficiency, in Kentucky, we use 10 and 50 mesh.
Mm-hmm.
I was always interested in knowing if there was data out there that validated our assumptions. We assume 100% effectiveness at the less than 50 mesh, 50% between 10 and 50, and 0% when it above 10 mesh. But I was curious, in the table you presented on your efficiency, you present a mesh size and the efficiency for that specific mesh size.
Mm-hmm.
Would it not be more appropriate to look at a range? Like,
yes. So it was really, and that probably is a table that needs some reworked.
like you had a mesh size,
Pull
so
up.
mesh size, the efficiency was 60%.
It's for a range. So how that could be interpreted. Let me pull up soon so I can share again. How that really should be interpreted. Let me find, there we go. Here, I think this is what you're talking about, right, Frank?
I Yeah, I see economics of liming example.
Oh. There we go. Does that work?
Yeah.
Okay. Yeah, so that would be essentially the efficiency of those particle size that passes the particle size, right? So essentially they're assuming that, and you know how we calculated efficiency was that the 4 to 8 mesh would be this 19%. The 8 mesh size, 8 to 60 would be the 30%, and 60 plus would be 70%.
Okay.
And so the numbers that are in place right now for the state of Iowa were 0.1, 0.3, and 0.6. And then when you kind of add those all up and put them out of 100, the 0.16, 0.24, and 0.6 are what we came up with. So it is a range. It's really just improper label on the table.
I see. Yeah, thank you.
Mm-hmm.
Yeah, that 8 to 60 is a large range there.
It is, and that's why we thought the 20. You know, Wisconsin here we use the 20 mesh sieve instead of the 8, and I think that probably catches a little more of that medium particle size better.
Yeah, I guess so. Looking at my numbers, then we use 10 and 50, and we assume 50%. I guess that's, you know, compared to your 24% for 8 to 60. But
yeah, the liming analysis, I would say, you know, in terms of the first lime effort is something that, you know, obviously isn't the first priority, but it's something that could be discussed as well, because I think lime analysis across the country is very different.
Yeah.
I think this whole thing as we kind of unravel the fabric that we've been using for recommendations. I mean, we got the soil issue, we got the incubation study, we got the buffer pH. I think this is as big a component as anything, because you've got the 2 ramifications. You've got the particle size distribution, and then you got whether it's how much magnesium's in that line. You know, that's an added factor. So FYI, everybody, Amber posted on the notes in the chat session there about the recent publication there on particle size that she got published. So any more
I can't
questions?
take too much credit. Dan Sullivan really led it and then let me be a co-author when I first started. But yeah, it's interesting. And we found something slightly different than what John suggested. Was we did not find that the finer it was that the pH went higher. It just got there faster. Was all we found, which is great. I mean, which still has a benefit for some folks depending on what they're doing and what their objectives were, but it's a little different than what our guys are claiming in the region, that, you know, you just add a little bit of their stuff and it'll go up to the same pH as a lot of regular ag lime, and we just didn't find that to be the case.
Well, it proves itself, right? Finer lime, the stoichiometric just pushes faster. So
Right.
Yeah.
Right. Yeah.
One more question, and we'll move on. Okay. Well, you know, I tell you this, I find this fascinating only from the standpoint is, you know, I'm more the chemistry guy and more the lab guy, but I really thought what you made the point about the difference between the sources and the fineness really makes it is. And probably something when we move forward with this program, we need to take that into consideration as one of the components we're going to have to focus on. So, okay. I know we're limited on time. I've got another Zoom call starts in 8 minutes. So I want to give everybody an update and then talk about the next meeting. So we formed a first line research subcommittee that's starting to build, you know, how this program is going to go off. And I will share that outline with everybody. That committee is composed of Frank Sikora, Luke Gataboni, and John Spargo. And we've just kind of had one long discussion about what we're looking at here in terms of the test parameters we want to do, the soils we want to collect. Actually, we kind of went down the rabbit hole on that. We're going to look at physiographic regions right now across the country, and we're probably looking at about 120 soils that we're going to collect for this study. We're still working out a couple of the other things, but I will be happy to share that with everybody when we have a more firmed up outline that for the next meeting. The last thing is I want to mention here is I want to start forming subcommittees to work on different tasks. We have collected most of the Lyme recommendation data from all the all the land grant universities that have current Lyme recommendations based on those 6 soils that I sent out. I'd like somebody to volunteer to be in charge of that committee. So I would like this group to kind of look at that data and kind of parse it out, what they find in it. I mean, we know there's differences in the Lyme recs, but I think there's a big enough metadata set there that we can start have a subcommittee kind of pick that apart. So somebody want to volunteer to be the chair of that subcommittee? I'm looking like 2 or 3 people, maybe 4 involved in that. I will share with you the Excel file with all this information.
Bob, I can do it.
Okay, very good. So I will share that with you. I'll also share all the soils data that goes with that data set. And I'd like that group to come back on the 20th of June and give us a brief overview about that. So John, you get to pick out who you want to work with on that, and anybody else who wants to volunteer on it. So that's just about it. I'm looking at the 20th of June to have our next meeting on that Monday. So, and we'll try to get the Zoom links kind of updated so everybody gets on board off of that. I know it's going to get into the summer travel season and everybody's got other things going on, but I want to keep this momentum going. So, okay. Any other comments? Cool. Well, this thing's going to be recorded. I want to make sure we get that shared with the rest of the people who couldn't attend today. And I guess with that, I will say, everybody have a great, what's left of the month of May. Hopefully it won't be too hot in Oklahoma for Brian. I'll
Just share some of your rain.
Hey, I wish we had some to send.
Yeah, I know you.
Since the 18th of March, we've had 0.6 of an inch here. It broke a record, driest April in history here. No rain. We had absolutely no rain in the month of April. So.
Well, I think we took it all. I think we're ready to share.
Well, if anything, somebody needs to send it to the West Slope because the Colorado River is going to break records for low water heights on all the dams this year. The projection is Hoover Dam will shut down in August for electrical generation. So. Okay, very good, everybody. Take care. We'll see you next month. Bye.
Thanks, Bob. See you.